Hello, hello. Welcome to this live stream. This is Founders Q&A with Fermyon. My name is Sohan Maheshwar. I'm a dev advocate at Fermyon. And we have Matt and Radu. Matt is the CEO of Fermyon, who was bobbing his head along to that intro music you just heard. Yeah, it was pretty good. Uh, and Radu, of course, is the CTO of Fermyon. So how this works, folks, is this is Q&A where you can ask us questions. Today, we will be talking about a new feature that we just launched called Serverless AI Inferencing. We'll show you a couple of demos. We'll talk about our architecture. We'll also talk about how we actually came up with this idea and also some of the use cases that you as a dev can potentially build with this feature. Matt, Radu, welcome to the show, I guess.
Yeah, thanks for having us.
Yeah. Okay, Matt, let's get straight to it. What did we just launch? Just tell us a bit about it.
Yeah. So last week we launched what we call Fermyon Serverless AI, and really this is an AI offering really designed for developers to be able to do AI inferencing against large language models like Llama 2 or like Code Llama. And so there are kind of two pieces to this. Inside of Spin, the open source developer tool, we've added all of the hooks so that you can run these kinds of things locally. It'll use your CPU by default, so it's not going to be the fastest LLM inferencing you've ever experienced. But we upgraded all the SDKs, so you can use TypeScript, you can use Rust, you can now use Go to be able to write code that, in addition to doing all the regular stuff you normally do with Fermyon, you can use for AI inferencing. And then on Fermyon Cloud, if you haven't seen the announcements, and we'll talk about this a lot more today, we partnered with Civo and Deep Green to provide very high-end A100 GPUs to be able to do AI-grade inferencing. So what might take you 5 or 10 minutes even to run locally, an inference running locally, will take just like a second, 2 seconds, 3 seconds running inside of Fermyon Cloud. So it's like the easiest way to run this inferencing, whether you're in your kind of inner dev loop or whether you're deploying your kind of first AI application out there.
Awesome. Yeah, I'm so excited. I of course played around with this feature, and later on we'll show you how you can also get like into the beta and play around with this. Radu, I heard from a little birdie, but actually it's on our blog, that the idea for this was on a flight to India when the two of y'all traveled, for like a meetup tour of India. Tell us a bit about that.
Yeah, Matt definitely tells the story better, so I'll hand it off to him really quickly. But the TLDR for this is Matt and I had a really long flight to India in June, and I may have downloaded a few language models to play around with
As one would.
during the flight, as one normally would. I'm told that's what people do on flights. And by the time we landed, we had a rough prototype of like playing around with a very, very rough idea of what if we could run inferencing for language model from WebAssembly and from Spin applications. So I'll hand it off to Matt for the dramatic interpretation of that story.
Thanks. Because I had flown from the US over to Frankfurt, and we met at the airport in Frankfurt. So I was already kind of tired because I'd already had a 9-hour flight. And so we're sitting there in the airport, and Radu says, "Yeah, I downloaded some large language models, and I'm going to play around with them, and this is pretty exciting." And he showed me a demo that was a really, really slow demo, and I was already exhausted. So I'm like, "Oh, that's nice." I mean, it was like probably the condescending, "Oh yeah, sure, yeah, you're gonna build a thing with an AI, yeah." So we got on the plane. And we're sitting next to each other, and we had dinner, and Radu was giving me the basics, because really at that point I had never really done much in the way of AI inferencing. And so Radu was kind of explaining to me the basics of what he wanted to do. I think, wasn't Alpaca the model you had at the time?
Yeah, I was playing around with that was the sort of the most the most performant permissive model that you could play around with, the model trained by Stanford based on Llama. So I was playing around with Alpaca, the fine-tuning there, yeah.
And so we had dinner on the plane, which was kind of your usual airplane fare, but I was exhausted. So I'm like, Radu, I'm going to sleep for a while. And Radu pulls out his laptop and says, "I'm going to code." And I'm like, "Okay." And he said, I'm going to see if I can build build a spin extension that runs LLMs. And I'm like, I mean, I'm sure I'm using my doubting Radu voice, which I should know now. I should never, ever do. I'm like, oh, okay, knock yourself out. And I was just out like a light. I mean, I was so tired after that first flight. So we must have been like 4.5, 5 hours into the flight. And I did kind of that like wake up kind of thing and blinked open. And Radu was like looking down over me from the seat next to me. He's like, oh, good, you're awake. And I'm thinking, I'm not awake. I just blinked once. He's like, I've got a demo. So I sat up and he showed me the first demo of AI inferencing inside of Spin. And again, this is all local, but even by that point, he'd gotten it faster. It just kind of exposed a couple of methods inside of a Spin SDK and showed off. I'm trying to remember. I've been trying to remember since then what the first thing was that you tested. I know that by the time we were on the other end of this trip, we were testing some more sophisticated things like trying to get it to print out JSON output and things like that. But do you remember what the original prompt was?
No, I think it was a sentence completion around my favorite theorem is, and let it generate with whatever. Yep. Yeah. So that I think that was the first thing that we ran on an airplane.
So I went back to sleep. And then, so we did, I think we did a total of, from start to finish, it was about 11 days as we did our trip around India with Siam from Sivo, with Rajat from Fermyon, and we went city to city. And a lot of times we were doing meetups in the evenings or conferences on the weekends. And so we found mornings and early afternoons to be pretty available. And so, we'd sit in the hotel lounge area and Radu would hack, or we'd talk through some of the details of how this might work. And it was really exciting because, for me, it was really exciting because I came into this having sort of like a vague view of how a developer might maybe use AI in their day-to-day development life, right? Like, oh yeah, maybe they do a chatbot, right? And a kind of vague idea that maybe we could do something that would be interesting to developers. And by the end of the trip, with Radu making that progress from the flight to just where we were when we were sitting in an airport lounge again at the end of the trip, running speed and performance tests with GPU access and going, this is a thing. Developers will be able to write AI-based inferencing inside of their apps alongside all the other features we provide, and they'll be able to build kind of this new class of things. And the performance is turning out to be really good. As Radu was tuning it, and as we were starting to look at what other people were able to produce, the performance was looking good. The developer experience was looking fantastic because there weren't any REST APIs you needed to do. There were no credentials, nothing like that. And you had that local developer experience for when you wanted to test something local. And then we knew, and then we spent the last night of the trip in an airport lounge, sort of brainstorming about what this would look like in the cloud and what we could do if we back this with, AI grade GPUs. So it was funny, conference trips, sometimes they're exhausting and you get nothing done. Sometimes in a case like this, a surprise little plane demo becomes a thing. And it was really, really cool to see it launch about 6 weeks after that trip was concluded, when last week, Sivo Navigate and at WasmCon.
Yeah.
I mean, yeah.
And the thing that I'm most excited about refining that initial idea is coming to getting to the point where we launched this, where we refined it to be really the building blocks for integrating some AI capabilities into your existing serverless applications, right? For looking at people who are by no means AI experts, or at least are getting started, or not have that either the expertise or the budget to set up inferencing infrastructure that can be sometimes prohibitively expensive, and just be able to use the familiar tools and build a serverless application and not have to manage external services. And the thing that excites me the most about this is basically being able to integrate with everything else in Fermyon Cloud. Things like key value storage to cache inference responses and cache language model responses, and then use the SQL database in Fermyon Cloud to store traditional relational data, but also embeddings, which are a thing that we might get into at some point later today. But really use the Fermyon Cloud SQL database as sort of a vector-ready database. We've been phenomenally happy with how the Terso database has been running, and allowing us to do something like that, to use that as an vector, as an embedding in a vector database, and then use everything else that you have, like a data service in Fermyon Cloud, and just integrate AI capabilities into your existing serverless apps.
Yeah, yeah.
Yeah.
For folks just joining in, this is Founders Q&A. We are with the CEO and CTO of Fermyon, Matt and Radu, and we're talking about a new launch about serverless AI inferencing. How this works is you can put questions in the chat. We'll be happy to answer them. Also, let us know where you're streaming in from. We'd love to hear from you, basically, yeah? So do send in those comments. I've also put the link for our blog about the serverless AI inferencing if you want to read more about it. Radu, so you did mention something about how the infrastructure for something like this is typically prohibitively expensive, but with this launch, we are sort of allowing devs to, access a feature like this about using LLMs and the such. So, can you tell us a bit about the infrastructure itself? Why is it expensive, and what's changed now?
Yeah. Traditionally, if you want to run a large language model, the hint is in the name of a large language model. They're usually pretty big models. And if you want to have good performance, you most likely want to run it on a hardware acceleration device like a TPU or a GPU or and if you want to run a model that is like 20 gigabytes, 30 gigabytes, 60 gigabytes of data, that model has to be loaded into GPU memory. And GPU memory is expensive. A GPU that is able to run one of those models is really expensive, which means that if you want to just have the model run in the first place and then have it run at reasonable performance, you probably need a pretty expensive GPUs like the latest NVIDIA A100s, for example, is a good example for that, which if you want to run one for a whole month, which you probably have to if you want to start experimenting with this or at least integrate with an existing application, it might cost more than your entire application stack combined. And sometimes that is prohibitively expensive for lots of scenarios.
So I know a lot of us, when we think about GPU, think mainly about graphics cards for playing games and stuff like that. And then, a couple of years ago, the buzz was around how GPUs could accelerate crypto. Why is it that a GPU is such an essential ingredient to something like a large language model or AI inferencing in general?
The answer is really simple. GPUs do matrix multiplications really easy. And language models are gigantic matrices that for every inferencing operation, you have to start multiplying tensors and each layer falls into the next one. And you basically, at the end, you're left with millions of operations and millions of computations that you have to do. And GPUs are really, really good at vector math and at vectorization and running computations in parallel on thousands of cores that they have available. So the more cores you have available in your GPU, the more CUDA cores in particular, if you talk about NVIDIA graphics cards, and the more GPU memory you have available, you're closer and closer to being able to actually keep the model in memory at all times and then use all the cores to run computations in parallel for all the billions of parameters that these language models have. So those two combined, cores and memory, really, really fast memory that those cores have access to, means you can run this really quickly. That doesn't mean that you cannot run this on a CPU. And we've actually started seeing a lot of progress on CPU inferencing. There are a bunch of projects out there like Llama CPP and a bunch of others that do inferencing on CPU, but they do it on RAM, like memory, and then multi-threaded CPU, which, given that you have orders of magnitude fewer compute cores and somewhat slowish sometimes memory, it means it's going to be significantly slower on CPUs, faster on GPUs.
Nice.
So when I was playing with models while we were doing the Q&A and the testing cycle for Fermyon Serverless AI, you had suggested to me that I download a lighter version of the Llama 2 model when I was testing locally on CPU in order to get better performance, because one of those tunable things is the number of parameters, but another one, I guess, there are other optimizations that are made to where a high-end GPU can do a whole bunch of work. When you're dealing with a CPU, you're really trying to reduce the amount of work, at least the amount of numeric calculations you're making, right?
Correct. And yes, you're basically, if you've chosen the model architecture, like in our case, we run Llama 2, which is the permissive model that Meta released, I don't know, about 6-7 weeks ago. once you chose the model architecture, number of parameters is the first thing to choose, right? The number of parameters literally means the number of like parameters that each model has. You can choose Llama 2 has 7 billion parameters, 13 billion parameters, or 70. There's another one that's right in the middle that's not been released yet that we're excited to try out at some point, a 30 something billion parameter. But basically, yes, the number of parameters in your model directly impacts the size of the model and automatically impacts the amount of GPU memory you need to have available to run that. And then in turn, because if you have more or fewer parameters, the time it takes to actually do the inferencing and actually compute and pass those computations throughout all the layers of your model. And that's just like, those are the flavors that you can train your own Llama 2 based model with however many parameters you want. There's a stories trained model that has 15 million parameters. That's really small, runs really, really fast, but it's tiny. Or you can use a 70 billion parameter and try to get as much context and as much information in the training data as possible. The second thing that impacts the performance of inferencing, you've chosen the architecture, which is Llama 2, and then you've chosen like 13 billion parameters, seems to hit the sweet spot between how fast it is and how reasonable responses are for a given scenario that you might have. Usually, like the model weights and the actual parameters that we get when we download the model from the official repository are floating points, 32-bit floating points. And there's a lot of research out there that indicates that when you go from 32-bit to 16 bits and then to 8 bits, the loss in quality is not noticeable, but the increase in performance is significant. So there is this emerging ecosystem of projects that run inferencing on consumer-grade devices like GPUs or like gaming GPUs or literally CPUs like your MacBook CPU, which let you run and download a smaller version of Llama 2 13 billion parameters that instead of having like the full precision, you can download it in 8-bit precision or 6-bit or 5-bit or even 3 bits, which you definitely get a loss in quality. There are a couple of benchmarks out there that you can actually look at to see the drop in quality that you can expect. But you run the same model and you get a sense of the type of response you get back, and actually run the same model but with a lower precision. So when we set up the local setup for Spin, we point people to potentially downloading a quantized version of Llama 2, which means the model will be, instead of 16 gigabytes, is going to be like 4, but it's significantly lower precision, but it runs faster. So this is all based on an emerging ecosystem called GGML, which is what we built in Spin, and Rust Formers LLM, which is a Rust project built on top of GGML, which is supposed to make it really easy to run quantized models on things like CPUs.
Nice.
What makes me happy about this is that you know all of these things, and yet the Spin SDK is so easy that I don't have to know any of these things at all.
And that was the whole point there, right? That the goal is to get someone who doesn't have to understand all of this and give them the building blocks to just, I want to run an inferencing. I've crafted this prompt. I've done a little bit of prompt engineering. I maybe know about one-shot or a few-shot inferencing, and I just want to get something done. And the demo that I'm going to show in a little bit is basically that, right? I have this task that I want to get done. I don't want to train my own model. I probably would know where to start, but I don't have the resources or time to actually train my own model from scratch. So I'm going to give this language model a try and just try to get it to output something that is reasonable to me. And we wanted to get people to be able to do that very easily, but also give them the sort of options and tweak parameters that you can pass to those models. So things like temperature and the number of tokens and top P and top K, things that even as you get deep down into understanding how to tweak and how to pass options and parameters to a model, you will start bumping into. We let you like set those because it's an integral part of how you actually run an inferencing operation. So if you have no idea what they are, you don't have to think about them. We do try to set some sensible defaults, but if you do understand what they are, by all means,
we'll get to the demo, Radu. We'll get to the demo very quickly, which I'm excited to see. For the folks just joining in, this is Q&A with the Fermyon Founders. So if you have any questions or if you just want to say hi, the comment button is right there. Tell us where you're viewing this from as well. We'd love to hear from you. We are talking about a new launch, which is our serverless AI inferencing launch. And we're just talking about, like the large language models and how some of them have, what was it, 70 billion parameters, Radu?
You can run locally. You can run the Llama 2 70 billion parameter, and that's
good luck to your macro CPU though. Oh, Vimal is here. Hey, Vimal. Thanks for joining in. Let us know if you're building any cool stuff on WebAssembly or Spin or AI. We'd love to hear what you're building. Before we go into the demo, we spoke about how we're giving devs the power to actually use large language models faster, cheaper, better. But what can someone actually do with this, Matt? So what sort of use cases does this unlock if I'm a dev and I want to add this to my app?
Yeah, and so to back up to that first part you said, I think the web started thinking about this is the way databases started, relational databases, right? If I go back to the beginning of my career, I worked with DBAs, and DBAs, database administrators, at that time, I couldn't write any of my own SQL, or at least I couldn't execute my own SQL. I'd have to write it and then ship them something, and they'd tune it and they'd make stored procedures and they'd give me back a stored procedure and I could call it. And there was very much at that period of time this kind of feeling that that regular developers, that full stack developers, that web app developers couldn't handle writing their own SQL, right? And that kind of perspective on things just sort of fell by the wayside and rather quickly. And these days, I think any of us who consider ourselves full stack developers, we can write SQL and optimize it and build tables very effectively. It turned out to not be the kind of rocket science that we thought it would need to be. But if you peel back the SQL layer, right underneath that, database theory is very dense and very difficult, and specialists are specialists in that field. And I think AI is taking that turn now too. There was a sense only a couple of years ago that AI was the domain of people with PhDs, right? And that only people with a lot of academic knowledge and deep understanding of how these things worked would ever be able to make use of these. And we would have a class of engineers that were called AI engineers. And it turns out that there is a class of engineers called AI engineers, right? They train models. They often will do the tuning on models. They will work to improve the underlying technology, just like there's still a class of engineers that are database engineers, that are experts in that field. But what we've started to notice, and I think ChatGPT was the thing that sort of lifted the veil on this, was that, it turns out that once you get up to a system like an LLM, then suddenly an engineer can work very efficiently, getting started with the simple statements, the prompts that are just asking questions, and working our way into things like Radu was talking about with temperature and things like that. And we can all kind of do that. So I think that AI engineering is just going to be part of our regular toolbox, particularly the AI inferencing, and that it's just a thing we'll use alongside SQL databases, NoSQL databases, caches, Redis, all the stuff we normally use, right? This is just one more tool. So when we start thinking about ways that we can use this, then we should think about, okay, what are the kinds of things that it would make sense for me to build? And we've already kind of seen the rise of the chat interactive models. So yeah, you can build another chat thing, and there are many yet to be built that'll do useful things. But what are other things you can do? One of the engineers at Fermyon, Caleb, he wrote this sentiment analysis thing where you could type in a sentence, and the large language model would give you back an analysis of what the mood of the person who wrote the sentence that's called sentiment analysis. Is a pretty cool technology that's been around for a while in very specialized forms. And this is just a super awesome, very generic way of using that theory kind of in practice. So we've had a good time playing around with that, typing in sentences and like, I like jalapenos, or they're jalapenos on my food, because some of us would view that as a very positive thing and others maybe negative. So they're fun things you can do with these sentiment analysis tools. But it would, you could think about rolling that into a product you were doing, right? Wouldn't it be nice if, you could have something say, oh, a very negative response came in on a GitHub issue. You might want to address this one right away, versus, a dozen Me Too's that you don't really need to go look at the notifications or anything like that. It can be a really helpful tool to help you prioritize work. A couple of people in Fermyon, Chris and Mikkel, had worked on projects where they took the content from our blog and loaded it into the LLM. And I think, Radu, I think you're going to show a demo of this. So I won't go too far into the details, but once you have your own content in there, then you can begin asking the LLM questions about, here's an article. Can you provide 3 links or 3 other articles that are similar to this that we should include in the related links? Or, can you tell us, can you take this article and provide a tweet size summary? I guess we have to call them posts now. A post size summary where I can put this in there. So there are all kinds of things. And really for us in the LLM space, the way I've been starting to think about it is, what are the problems where I have a body of text and I need to produce some other kind of text, and it's kind of basic work, like research work or summarization work or analysis of a text kind of work. So you get summarization, sentiment analysis, recommendations, rewordings of things. Those are all great things to be able to use an AI for.
Nice. Okay. So, Radu, we're going to show a demo, but we have people watching our stream. Thorsten says hi. Hi, Thorsten. Thorsten's a very familiar name in the WebAssembly space. I know for a fact that Thorsten's built a pretty cool app with the same serverless AI inferencing. So, Thorsten, if you want to put the app link in the chat, please feel free to do so. We could maybe even test it out and play around with it. We have a couple of similar questions from Vimal, Quilt, and Thorsten. And Radu, maybe once you show the demo, you could answer these. So Vimal, Thorsten, we will get to your questions in a bit. Radu, do you want to share your screen in the meanwhile for the demo? And just as
yes.
Radu does that, this is Fermyon Founders Q&A. You have question and answer time with the CEO and the CTO of Fermyon. We're talking everything about AI and serverless AI specifically, and how you as a dev can actually use this feature and get access to large language models that are 100 times faster than running your own models in the cloud. So Radu is going to show us a quick demo of how this works.
I will have to grant it permissions to record my screen. So in the meantime,
you might have to restart your system. No worries. So we can take Thorsten's question for now, which is, so we heard about Llama 2 being part of the party. Are there plans to bring other models to Fermyon Serverless AI? Matt, do you want to go? Should I go?
Yeah, you start. I'm going to, and then
Yeah. So as Radu was saying earlier, I think we support 2 or 3 models which are different versions of Llama 2. Hopefully, we will soon be supporting like a bring your own model type thing. Radu is going to show later on an embeddings thing where you can actually bring relationships between certain texts or certain data that you already have. And Matt, you and me, we were both at this event called Sivo Navigate recently, where we showed this demo to a bunch of people, and they all commented about how just a year ago, without LLMs, just doing something like this would have taken an entire team, right? And a vector database and a data scientist, and now it's a simple, almost like an API call.
Ooh, we should talk later on about vector databases. I think that's one of those terms that suddenly you see articles about it and people are asking questions about it, and yet it's kind of a misunderstood or underestimated kind of technology. But so Radu, there we go. So with that, I'll shut up and Radu can go.
I'm hoping everyone can see my screen. We are going to play around a little bit with an application that Caleb from our team wrote, which is the application that Sohan referenced, which is a very, very simple sentiment analysis application, which you could probably do a much more accurate implementation using a classification model, but you would have to understand what that is and train one on your data. And We're going to try and see whether we can build one using a Llama 2 chat model and just playing around a little bit with prompt engineering and starting to integrate with things like key value storage and deploying this over to Fermyon Cloud. So the application is a Spin JavaScript application written by Caleb. And it has a couple of components. This is the primary serverless API endpoint, which is a TypeScript application. It can access the key value storage, and in the latest canary of Spin, we have this new thing called AI models that you have to allow, put them in an al list in your component configuration. So this line 13, says that this component, sentiment analysis, is allowed to access the Llama 2 chat model. None of the other components is actually allowed to access anything. And then the other thing that we're interested in is just a simple UI for our application. So let's have a look a little bit at our JavaScript application. So, TypeScript. So really simple. We have a request to analyze a sentiment, which takes in a string, and then something that returns negative, neutral, or positive. So that's pretty simple API for our application. And then we have a router that defines our API sentiment analysis route, and then a catch-all for 404s and for every other route returns a 404. So this is, if you've ever written a Spin TypeScript application, this is a handle request function, takes a request, returns a promise of a response, and then in the implementation, we just pass it on to the router, which basically pass it on to the classify model method. So classification methods, as you would expect, you have to decode the request body. So we take the JSON from the request body and try to convert it as sentiment analysis request, which, if you remember, is just a JSON object with one field called sentence. And then here's where starting to integrate with the rest of what you can do with Fermyon Spin and then Cloud starts to be real handy. We will search the key value store to see whether that particular sentiment, that particular sentence has been analyzed before. Even with a really performant infrastructure to handle inferencing requests, it still takes a couple of seconds to handle that. So if we already executed that inferencing operation for a particular input, we definitely want to just return it from a cache. So we're using the Spin key value storage and Fermyon Cloud implementation when running in cloud to just use that. So this is
the key is the sentence that the user entered, and the value, if the key is present, the value is the last thing the LLM answered for that one.
Correct. Yeah.
Okay.
There are ways to improve this. So we accept contributions for examples. There are two pretty simple ways to improve this. The first one would be to get a hash of the sentence, so we wouldn't store a full sentence as the key in the key value storage. That's not necessarily ideal. And then the second one would be nice to get a similarity search, so we wouldn't have to have an exact match on the sentence. So if you're interested in playing around a little bit with the vector embeddings and with the vector extension in the SQL database that we have, I would love to get this in the demo and basically show all the building blocks of what you can do with this. So once you get the key value store, if it's not in the key value store, then we call the model. And this is where I talked a little bit about the inferencing options. If you know what these are, like repeat penalty and repeat penalty for the last n tokens and temperature and top K and top P, you can set those and you can just tweak around them and see what output you get from either of those. But if you don't, in this case, the only thing we care about is we want at most 5 or 6 tokens in this scenario, which is the most of positive, neutral, or negative. Like anything more than that, it's probably the model returning some adjacent sentences around what we want. So we want to really limit the model to what it can output to 6 tokens. And 6, it was very much an empirical number that we came up with, which was we noticed that was the output size most of the time. So we just
I think so. Like if you were trying to generate a summary and it was supposed to return back paragraphs of data, you'd want to set that max tokens to something like 200 or something like that. But in this case, you just want in this case, you just want sort of like a 1-word response. So 6 tokens is about big enough to accommodate that, right?
Correct. Yep. Okay. 6 tokens should be enough to return neutral, positive, or negative. And then line 65, this is where the whole thing is executed, right? We have one function on a new LLM namespace in our SDK that will vary from language to language. In TypeScript is just llm.infer. And this function takes the model, which in our case, it's going to be Llama 2 chat. This is what we've tested with. This is what we know is a good fit for our task. And then for our prompt, and then we pass the options that you can tweak one line up. And then the actual prompt is what we have to send to the model. And this is where a little bit of prompt engineering will become very handy. This is the prompt format that Meta released for Llama 2. This is what the model has been trained with. So this is what you will get the best performance out of that model. There are entire articles written about how to prompt Llama 2 chat. This is what we've identified as both the documentation from Meta and what we've seen works really well. So this is the system prompt, which is the sort of primary directive for what the model is supposed to operate under. And our scenario would tell it that it generates sentiment analysis, and it did respond with just a single word. And then here we do a little bit of what it's called few-shot prompt or few-shot inferencing, in which we show the model a couple of examples of queries, of input queries, and what it should respond, and basically give it 3 examples and then expect it to complete the 4th one. And in here, we just replace sentence under curly braces with the user input. So,
and how does this data influence the model, Radu?
It doesn't influence the model. The model has been trained. It's running somewhere, or we've started just in time. It basically is the input to the model, right? It's the input. This is translated to tokens, and then it's formatted properly in how the Llama 2 model expects. And then those input tokens are basically computed against all of the layers of Llama 2 chat, and that's basically the how it starts generating that. That's a starting point for what the model will generate. Like the prompt is always going to be the first thing that it's basically the starting point for what it generates.
Yeah, I think I'm trying to remember how you explained this to me, Radu. It was so good, but it was basically like you're giving the model information to help it zero in on what the space is that it should use to generate answers. Because again, you're dealing with this huge, giant data set that can be culled through. And so you kind of give it a personality in the sys, and you kind of give it some idea of what you're expecting back in the inst part. And then you say, this is what the user is asking, right?
Yep. If you take a step back, Llama 2 and most language models in general are basically text completion engines. Like their sole job is like the foundation model, like the base models. Their sole job is to continue a sentence or continue a prompt. Llama 2 chat is a fine-tuning on top of that base model that is fine-tuned on chat sort type of conversations, in which you have a user 1, user 2, potentially user 3. And then at the end, it's supposed to continue that conversation in a coherent way. And the more information and the more specific information you have in the prompt, and the more you try to make the model just the inferencing operation use the prompt and try not to use anything outside of the prompt, the more accurate information you're going to get. Of course, that's all dependent on your use case. If you have a very specific use case in which you have to write down theorems, it'll probably not do a good job with the training data. You will have to either do a little bit of prompt engineering, or you would have to fine-tune your model. But for tasks like this, like a simple task of just tell me whether the sentiment of the sentence, of the input sentence, is neutral, positive, or negative. Language like Llama 2 is particularly like really good at this, and that's what we're using for this.
As a super quick aside before you go back to the code, we've used the phrase fine tuning a couple of times. That's actually a technical term when you're dealing with models. Do you want to give like a 1-2 sentence clarification about what fine tuning means?
Yep. So in this LLM.infer function, the first argument is the actual model that we're going to use. Llama 2 chat is, again, as I mentioned, Llama 2 is the foundation model, the base model, and then Llama 2 chat was specifically trained and tuned on chat conversation. So Llama 2 chat is a fine tuning of Llama 2 base. Which it's been given a lot of new training data, for specifically chat conversations. Fine tuning is basically is the operation of taking your data, your internal data. In this case, it was the chat conversations, and training the last parts, the last layers of the model with that new additional data, like prompts, and then you show an example, and then you run the training on your whole data set for a few epochs. And then you generate a fine-tuned model. So basically, Llama 2 chat is slightly different from the Llama 2 base model, but it is a different model based on that foundation model. And we can get, at the end, we can get a little bit into experiments to run fine-tunings on using Spin and how we're thinking about letting people bring those in Fermyon Cloud. So.
Nice. Okay. Take a quick pause there and just, we have a couple of questions. So first, Vipul says, hi all. Hey, Vipul, thanks for joining in. Where you joining us from? And yeah, let us know if you're doing anything in the WebAssembly or serverless or AI space. Love to hear the sort of use cases that people are actually out there building. We have a question, Radu, and maybe this is time you take a question from Vimal Quilt, which is, what are the transformer architectures supported? Of course, we have things like BERT and Roberta and VIT, etc.
Yeah. So there are two places where we can run models. One is Spin, the other is Fermyon Cloud. Currently, Spin and Fermyon Cloud are able to run exactly the same models, Llama 2, Llama 2 Chat, and then Code Llama. So those are the models that are currently available in Fermyon Cloud. So we have Llama 2 Chat and Code Llama. There's one, so those are for inferencing models. In terms of other architectures for inferencing models, we are experimenting with letting people run other types of models, like potentially Falcon and Bloom and a few other types of language models. Those are just different types of models, different architectures based on transformer architecture. So we are definitely interested in hearing from all of you in terms of what specific types of models and architectures you would like to see for inferencing models. There's one more operation that you can run both in Spin and in Fermyon Cloud, and that is embeddings. And that is taking input text and generating a numeric representation that can be semantically searched against similarity against the other inputs. And basically that paraphrasing, what that means is you get the ability to search a database for the top results, the top entries that are close semantically to a user, to an input query. So for example, if my input query is, the weather is amazing today, semantically, those, what you might find in the database as top matches for that are sentences or paragraphs that talk about the weather, that talk about storms, sunny days, and things like that, like semantically close to that. So for embeddings, we do support currently the sentence embeddings model, all mini LM L6 V2. And there's a link in our documentation about the specific model you can fetch from Hugging Face. But we currently support just that one who wanted something that is popular and simple and fast, really fast to generate those sentence embeddings. If you have specific scenarios in which you would like to generate sentence embeddings for languages other than English, or specifically fine-tuned for other scenarios, I'd love to chat about that. And we'll have a little bit of a conversation at the end for shipping fine-tuned models to Fermyon Cloud, because as I mentioned, currently you can run Llama 2, Code Llama, and then the sentence embeddings model for embeddings.
Yeah, Vimal, hope that answered your question. Yeah, keep asking us more in case you didn't, or if you want follow-ups as well. I've also posted the link for things around quotas and service limitations for Fermyon Serverless AI. These are some questions that we get asked about, things like what models and what are the quotas. So yeah, you can check out that link.
So you were going to explain. So we were just at the llm.infer. So it was model, then prompt, and then options were the three things you pass in there. And we talked about options and model. Then we got on prompt, and then I got you way off track. But at the end of that prompt.replace, that would just replace sentence in the prompt that we looked at with whatever the sentence was that the user supplied.
Yep. The idea here is on line 39, we basically replaced curly braces sentence with the user input was, I had an amazing day, analyze the sentiment of that sentence. That's basically paraphrasing what that does.
So and what happens when you run an infer? Oh, go ahead. Sorry.
So the one thing that I do want to point out before I get to that is this is all you need to do to generate an inferencing and to run an inferencing request on Llama 2 chat in both Spin and Fermyon Cloud. There's no other setup. There's no API keys that you have to set. This is literally going to run on your machine as you will execute Spin up, and then it will run on our infrastructure or on Fermyon Cloud when you run it in Fermyon Cloud. There's nothing else that you have to do, and I will just no cold starts or nothing, or no waiting for a GPU to come up or anything like that. It's that we tried to make it as easy as possible, and just two lines of code to actually run an inferencing operation. Cool. Before we get to what happens, this is a Spin application, so we can do a Spin build, which will run npm run build for our application, and then generate the WebAssembly module, and then we can do a Spin up, which will run our application locally. It has 3 components. I'm gonna try access the UI for it, and this is the sentiment analysis sample running on my machine. It's on localhost 3000. If you have a look here, you'll see my CPU going wild when I'll send an inferencing request here. So I'll send a sentence called "This is amazing," and hopefully it's never been executed before. Yeah, so sentiment not found. Sentence not found in key value store, which means Spin will load the large language model from disk and basically run the inferencing operation. Take the prompt, tokenize it, feed it to the model, and then perform the inferencing on our application, on our query. If I do take the same input and do "this is amazing" again, this will be fetched from the key value store. So it was already in cache. We don't have to run it again. But then if I do "this is not amazing," this will take a little bit of time again, depending on going back to our conversation about model size and quantization. This is like Llama 2 7 billion parameters, or the smallest of them, quantized to 3 bytes. So really, really bad performance if I was going to, quality, if I was going to get it to summarize text or generate something for very specific, very small examples, for very small queries. This should work well, and we can see this is not amazing negative. So this is running locally. Go ahead.
I was after yesterday. How about I want a new iPhone or a new watch?
And an expensive watch. I hope it's neutral. It's the only,
I'm
only
curious if
correct
that would
answer.
be neutral or negative for saying it's expensive. Yeah.
And I do want to point out that, again, it takes 7, 8, 10 seconds to run this locally because it's, again, running on my machine.
Neutral. Okay. That's
yeah,
good.
It was neutral. And then you can once you run the application locally, so Spin build, Spin up to run locally, and then Spin cloud deploy will deploy our application to Fermyon Cloud. I already did that right before this because network during the live demo. So hopefully, okay, let's see that it's actually running. This is amazing. And I suspect that was fetched from the key value store. So this is really, really amazing. And this will, again, that was, I've never written that sentence before.
Wow.
That was literally we sent the request to Fermyon Cloud, instantiated a WebAssembly module to handle that. And then when it came to LM Infer, sent the WebAssembly request to a GPU 100 and CVO's infrastructure, loaded the model, performed the inferencing, and then returned a response back. And that was that fast. If you want to actually see how fast that is in a chat-like application, hello, what is? It's not an inferencing demo without a chat application. And again, that is literally cold starts for inferencing. Our application is instantiated just in time to handle a request, and then the WebAssembly module is shut down. When was DaVinci born? And hopefully it'll, so this is running on deployed to Fermyon Cloud. It's a simple chat application. And you can find all the examples on our GitHub.
That's a good place to point out that, one of our passions from the day Fermyon started was to try and be more efficient with the resources in the cloud, right? We know that the average server is sitting around 80% idle. And one of the advantages of serverless is you're starting running to completion and shutting down as fast as possible. And WebAssembly gives us this technology that allows us to start up in under a millisecond and be executing code and then shut down. And because it's so fast, we can very efficiently interleave lots and lots of requests from lots and lots of different applications on the same compute hardware. And what you're seeing here in AI inferencing is essentially just like an extension of that same idea into the GPU world. So instead of locking down a GPU and allocating it to the server for a long period of time, as we would do normally, particularly in like the Kubernetes space that I'm really familiar with, now what we're saying is, we're just going to use that GPU just long enough to do that inference, and then we're going to put another inference on there and put another inference on there and just work our way through a queue of tens, hundreds, thousands of different applications that are doing these inferences. And part of the reason it's so fast is because the infrastructure is just built to cut off all that startup time. And as Radu and the engineering team at Fermyon built this out, intelligently and carefully sort of managing the caching of data and things like that on the systems that have the GPUs means that we can start up much faster. And consequently, once you get to this giant behemoth A100 GPU, you're really using it the way it's intended to be used, right? To just squeeze all the performance out of the GPU and the memory available there and return a response. So it's really kind of cool to see that just compared to your local inference and that one remote inference, to see the speed and performance difference, even though that one's, literally on the other side of the world from where you are. Because I believe you're in Europe right now, and that the data center you just hit is in probably California, I would guess. US East or US West, so either Virginia or California.
Yep.
Yeah, and the thing that I would like drill down the point on right there is the only reason we're able to achieve this is because we using WebAssembly to as the execution and deployment unit for that workload means that the only time a fraction of a GPU is assigned to a workload is while there's an active request that needs an inferencing operation to be executed. Execute that for however many seconds it takes to run the inferencing, and then the next application is going to be assigned to that GPU, and then the next, and then the next off the queue. So it's ultimately significantly more efficient in terms of resources and how we use resources in our implementation of cloud, but also means that a user request will never have to wait for a GPU to be up, or for a GPU to, or for a VM or for a container to be fetched and then started, and then for the VM for the GPU to be assigned. It might wait in a queue while all the GPU fractions are busy crunching inferencing requests, but it's only going to wait for whatever it takes for the first fraction of the GPU to become available, not for a full container to be fetched and for 10 gigabytes of model to be downloaded and then the GPU to be attached to it. So it's a sort of a win-win for everyone involved, both for us and the efficiency that we run our infrastructure with, and then for users who hopefully will never experience minute-long cold starts to run one sentiment analysis operation.
Yeah, for folks, if you're interested in trying this out, just go to fermyon.ai. There's links to documentation, sample apps, and also a way to sign up to the beta so that you can get access to this. It's a lot of fun to play around with. In fact, Thorsten, who's in the comments, who made a very cool example, which I'm sort of stealing off of social media as well, which is pete.fermyon.app. Right? So you can post any text and it would change that to a typical pirate speak. So I picked out Taylor Swift lyrics because I know Matt's a fan. And let's see what happens.
This is because Sohan knows I am a huge Taylor Swift fan, and that I dressed up in costume to go to the Taylor Swift concert recently.
Yeah, there we go.
Oh, that's amazing.
Yeah. And I don't want to lose the technical bits of what happened right there in order to generate Taylor Swift lyrics in the style of a pirate. There was literally a 13 billion parameter llama.
All of that science and technology has come up so that we could.
Yep.
Millions and millions of research hours have gone into making it possible for us to translate Taylor Swift lyrics into pirate versions.
Yep.
The emojis are a nice touch in there too.
Yeah, I wonder what the sentiment analysis says for emojis. So that will be a fun sort of test, I think. Yeah, we could try that out sometime.
My assumption is that all it would take to try this out is going to be a little bit of a few examples and few shot inferencing and giving it a few examples.
Yeah,
I'm curious for various emojis. Like smiley face, I think people are going to say that's like negative. The smiley face with nothing else is like
it's like the passive aggressive.
Yep. How good is the LLM at detecting sarcasm?
Not particularly good, or at generating haikus.
Poetry is a thing that the machines have not yet perfected for sure. We totally should do one of these streams though, specifically on embeddings, because once you start doing embeddings, the realm of possibility seems to really extend out from there.
The one thing that I do want to point out before moving on from like talking about models and talking about what's available and what will eventually be available, this is private beta, right? We just released this. We released it with a couple of permissive models that we know are popular from looking at what developers are asking for and what developers are using. So Llama 2 and Code Llama. We already do like sort of hot swapping behind the scenes when you swap between those two models in Fermyon Cloud, and we're improving that and optimizing how that works to the point where we're starting to prototype with shipping. We talked about fine-tuned models and how you only change the last few layers of a model. So I have an example that I'm unfortunately not gonna demo because of time and setup. That Llama 2 does not speak Norwegian really well, and there's someone on Hugging Face who fine-tuned Llama 2 chat 13 billion and fine-tuned it on a large data set of Norwegian language conversations, and the output of that is a 100 megabyte binary file that I can apply on top of Llama 2 chat. And suddenly Llama 2 can respond in Norwegian. And that's just an example, like a proxy for any custom data you might have that you want to bake into the model as knowledge. Go ahead, Matt.
I was going to ask a question, but you're still answering. So
yes. So and the thing that I'm most excited about with this is basically as part of your spin application, just shipping that 100 megabyte file. And that will be applied on top of like a 20 gigabytes or 30 gigabyte model at runtime dynamically and execute inferencing based on the whole thing that we just applied. So I'm really excited about that. It starts to give a glimpse of how you can customize it, how you can run custom models. The final thing that I'm excited about there is there's this research arm around language models for much smaller and much more specialized models. And so instead of having a general-ish purpose 70 billion parameter or 13 billion parameter, we have a 500 million parameter model that is just specialized for example, sentiment analysis. because you don't actually need the knowledge of when Da Vinci was born in a sentiment analysis bot. So having a very, very small model means you can run that on much fewer, or like a lot more, either fewer resources or pack more of those models on the same hardware. So significantly more efficient, and then starts much faster. We can run that on CPU only, and it's not going to be really slow. So a whole bunch of possible things that we can build around that I'm really excited about. And it's up to people who are using this and developers to tell us exactly what they would like, what you would like to see, and the types of things that you would like to be able to run in Spin and Fermyon Cloud.
Yeah, this is fascinating for me. And Matt, maybe you're best positioned to answer this, because what really are the implications of something as cool as this, right? Where you can bring like a 200 MB model on top of like an existing chat model. What sort of possibilities does that open up?
Yeah, and this is where the example I gave earlier about, training, being able to use your own website's data, for example, like say you build a specialized, say you build a developer application platform, and we'll just call it Spin just for the sake of, and we generate lots and lots of technical documentation about this, code examples, explanations of what's happening, blog posts that offer guidance. Wouldn't it be cool to take the model, take a large language model or take a specific language model and be able to have it trained up on that particular data, and then be able to generate responses much more specific to that? Everything from, and we haven't even talked about code generation at all, but that's another thing that Fermyon Cloud supports is Code Llama. But to be able to say, hey, can you spit out a Spin function that does X, or what Spin APIs would help me do this faster, or something like that, and to be able to train it. And this is where, so Radu, some of this can be done in prompt engineering. But generating embeddings and then storing embeddings in a vector database and then using it, querying those, that's a way to train a larger body of text. And then the sort of fine tuning or even building custom models are sort of the heavier weight applications of that, right? So you're talking about 100 meg or so, there you're in the fine tuning. Probably none of us, but probably some organizations are best served by actually generating their own entire model, right? If they have a very specific set of data to train on, a very specific kind of problem to solve. But I think most of us are really looking at prompt engineering as the easiest, embeddings as also quite easy, right? Maybe a couple lines of code instead of just some plain text. And then maybe where we at Fermyon want to be able to go in the future is figuring out how to do these fine tunings really extraordinarily well, so that it's easy for you to load up a fine tuning along with your application. If I'm using the term, if I'm a fine-tuned model or just a fine-tuning, I don't know which one of these two I should call it, but to be able to upload that and then get all of the benefits out of that. I don't know, Radu, you have anything to add to that about the kind of steps you can take to?
Yeah, I think you've seen we've seen a few of those techniques in the demo that I showed with the chat application, where I just asked when Da Vinci was born. That was like a zero shot inference. I didn't give it any examples on my own of what it should do. I just asked it a question and it responded. Few shot inferencing is basically giving a few examples, and again, it's just by doing the prompt. And then we start getting into, with embeddings, you start getting into something called retrieval augmented generation, in which, based on the input, like for example, if you take the Spin developer documentation, a bot for that, a user asks a question about how do I store data in the key value storage using Go, for example. And you take that input, search it semantically against the entire developer documentation in Fermyon Spin, and basically choose the top 5 results, the top 5 articles or top 5 sections in an FAQ, and then pass those as context in the prompt. Right, so it's still prompt engineering, but it's augmented by retrieving semantically close information from your database or from a data source. That hits a limit of the maximum context size you can ship. So, for example, if you have 10,000 words or 10,000 tokens, but words works well. If you have 10,000 words that you've written about how to do key value storage in Go, you won't be able to feed all of that to the current Llama 2 model. There are models out there that support a bigger context, but it's going to be expensive and you have to pass it every time. So for those scenarios, what Matt was talking about is basically taking all that data and trying to generate a fine-tuned model based on if your chat is your primary application based on a chat model, or if you have text completion based on a text completion. But basically what the state of the art is for this type of inferencing is trying out your scenario with directly talking to a chat model, then doing few-shot inferencing, then retrieval, augmented generation, and then generating your fine-tuned model. And to Matt's point, yeah, we're really excited about, for organizations that do have the ability to fine-tune models and to generate those fine-tuned weights, the last layers of a fine-tuning model, to just ship us those 100 megabytes of changes, the diff between the Llama 2 chat model and their data, and just load that and execute that. So that's the spectrum of what you can do with this sort of language models. And that's just language models. It's not even starting to cover not even other type of transformer models, right? So there are like the diffusion models that generate images, and there are a whole bunch of techniques and models on their own there. So if you're interested in running those, and if you're interested in contributing those and building support for Spin to be able to run those and then support those further in Fermyon Cloud, I would love to chat about that. All of that is open source in Spin, and you can run it on your own. You can experiment with all of that.
And a big part of why we wanted Fermyon Cloud's beta to be totally free is so that you can go out there and you can try this on our cluster A100s and get, be able to expect really good performance out of those kinds of things. And then, help us figure out how to better solve the kinds of problems that you want to do as you get going on your AI inferencing.
Yep, for sure. We have Dante also stopping by the stream. Hi, Dante. Thanks for stopping by. Yes, hopefully soon you will be able to layer this and bring your own models as well. Let us know what your use case is, what you're working on. We'd love to hear from you. Folks, since we are sort of out of time, and I think we'll be winding up soon, I think main question, how does one get started? Like, say there's a dev who's like super interested, wants to integrate a large language model into their application. What's the best way to get started? Radu.
I can take that one.
You wrote the guide, Radu. I mean, it should be.
I most definitely did not. So
it was probably Kenzie who wrote the guide. She's
Kenzie and Tim. Yeah.
Oh, Tim too,
The simplest way is sign up for the private beta. You have the link in the chat for how to request access to private beta. And start having a look at the examples. Both examples that I showed are open source. They're in our GitHub repo that we will share shortly, and basically have a look at how you can run that. The thing that I'm really enthusiastic about how we're rolling this out is you can run all of this on your own machine, right? There's no requirement to create an account or any of that. If you want to experiment with this on your own machine, play around with models, get it to output something that you want, develop on your own machine if you have the hardware. And then if you're interested in trying things out and not waiting for 30 seconds for an inferencing request to be executed on your machine, deploying Fermyon Cloud in the private beta is the way to go there. The one thing that we are exploring with, so Karthik and Caleb from our team are working on this, is if you don't have the resources on your machine, if you have an underpowered, or if you don't have a really overpowered workstation to run those language models on your own, we are working on a Fermyon Spin plugin that will let you run Spin up on your own machine, but instead of running the inferencing requests locally, it will proxy all of those to Fermyon Cloud, where you can run your requests on an actual GPU that is really, really, really powerful. So you can have the same local developer experience where you can iterate really rapidly. So you do a spin watch, so you can watch the source code as you make changes, have it recompile and start spin again. And then instead of running your on your machine and literally pegging your CPU to 100% for 30 seconds, instead running that in Fermyon Cloud. So excited to have that available soon.
Nice. We also have the Spin Up Hub. developer.fermyon.com/hub, a bunch of examples, plugins, templates for you to get started. Matt, I hear you wrote like a pretty fun one, which may or may not have referenced Monty Python.
Yes, yeah, I wrote one based on the Silly Walk Monty Python skit. Mine was, unlike Radu's code, which is like sophisticated and does interesting stuff, mine was like 12 lines of TypeScript. It was about the shortest AI inferencing you can do. It was the very first ever AI inferencing code I ever wrote, so I'm kind of proud of it, even though it's pretty, it's pretty much just a little toy.
No, but I think the cool part is with 12 lines of code, you can actually write something that uses a large language model, and it's so easy, right? You don't need like an entire team to sort of figure that out. It's
Yeah.
And I feel I feel the urge to point out the fact that you don't need an external service for any of the persistence or caching or config or any of that. If you run your application with Spin, you can continue to run it with Spin if you have the hardware. We do have GPU support in the Spin. There's a feature that you have to compile in and like choose the right version of your hardware acceleration. So if you have a GPU available, you can use it with Spin up. So you can use it and use key value and caching and SQLite databases and all of that. And you can use the same on Fermyon Cloud and have high available versions of key value, config, secrets, relational databases, and all of that. So you can literally run full stack applications that happen to do some inferencing on the side, or just build full inferencing applications that happen to use things like persistence and caching and embeddings and all of that.
And Spin 1.5 comes out this week, and that means we will officially have support in the Spin binary. To this point, you've had to either build from source code or grab the latest Canary off of our Canary builder. But this week, when Spin 1.5 is out, it'll be in mainline Spin. I'm really excited about that.
Yep, for sure. We have a question from Vimal again. Vimal, thanks for sticking around during the stream. Where do I check pricing plans for this serverless AI service? Well, we have some good news for you, Vimal.
While it's in private beta, it's literally on the private. On the starter plan, which is free for Fermyon Cloud. There are some rate limits that we apply so that everyone can have a good experience using the service. But for now, we don't have it. It's entirely free on the free tier. While this service is in private beta, we're trying to get a little bit of an understanding of the workload shapes and how the workloads look like and what our peaks and troughs look like and all of that. And in this process, we're trying to figure out what pricing should look like. There are a couple of options when it comes to the shape of pricing, whether it's per tokens generated or per GPU time, seconds, or some combination of the two. So if you have strong opinions about this, I would love to hear them.
And there will always be a free tier of this. This is one of the things that's very important to us, is to always make sure that any of our big services have a free tier offering, right? So that you're not stuck having to pay in order to even try any of this. But right now, it's all free. The whole AI thing is free with these certain rate limits that I know are on that URL on the bottom of your screen right now.
Yeah, and then extending the conversation about the free tier Fermyon Cloud, you will always be able to run 10 applications for free on Fermyon Cloud and run hundreds of thousands of requests and gigabytes of storage. And so that's always going to be the case, including the inferencing service.
Yeah, and to get in touch with us, Vimal, and the others watching our stream, we have a Discord. We're very active on our Discord, so just check out fermyon.com/blog/fermyon-discord. It is an active Discord community, so come join us there. If you have questions about getting started or about things like service quotas, we'll answer them for you. Right?
Yeah.
We do run these office hours once a month also. So you can always swing by our YouTube channel and click on the notify me button. Also, don't forget to smash that like button, and like, share, and subscribe, because I have to say that as well.
Yeah, and if you heard my dog barking in the background, that's because he is advertising for today's blog post, which is about him. I took a vacation recently, and realized that my family is inefficient when it comes to feeding the dog. So we wrote a blog post about using NFC tokens and iPhone apps, and nothing at all to do with AI and serverless, but it was
Does
a
it
fun
use
app.
AI? Yes, that was
Yeah.
my question.
I could like tap my phone on the dog food bin in order to record that I had fed the dog, and that way he was, I mean, we say, oh yeah, sometimes he missed a meal. He rarely missed a meal. The problem was every time anybody would come home, he would act like he was on death's door and, roll on the ground until he was up to, 5 or 6 meals a day instead of 3. But yeah, so we wrote a blog post, and he's barking in the background because he's vain and he's advertising for that.
Also, smooth segue, Matt. That was really smooth. Yeah.
One thing, my final thoughts on this is, please tweet at me and at us with any example you're building with the inferencing and AI, serverless AI feature. I would love to understand the type of thing that all you are building. Or post at us on whatever platform you are on.
Yep, that'd be awesome. And you can even contribute to the SpinUp Hub, your examples straight to the SpinUp Hub, link them to your GitHub repository, and be able to show other people and help other people figure out how to write their own code or how to download your code and use it and whatnot.
Yep. All right. We look forward to hearing from you folks and also joining us on our next office hours and YouTube streams and Discords and whatnot. Till then, thank you, Radu. Thank you, Matt, so much.
Yep.
And we hope to see you soon. Bye.
Bye, y'all.
Bye.